Welcome to Broadcasting Common Ground, the Deep Foundation Institute's podcast channel. In this series, DFI's Rumble, we will be speaking with opposing industry representatives, asking hard questions and facilitating a polite argument. In this episode, Ross McGillivray and Kevin Johnson discuss the installation, design and verification of helical piles. Sponsored by ECA.
Welcome to DFI Podcast, Broadcasting Common Ground. I'm Lucky Nagarajan, and welcome to Rumble, where we ask two guests to enter the arena and go toe-to-toe on topics relevant to our industry. How cool, right? The referee facilitates the discussion. So in this episode, my friend Tim Siegel joins us again to referee the discussion between Kevin Johnson, Senior Engineer with EarthTech LLC in Tampa, Florida, and Ross McGillivray, Senior Consultant for Ardaman and Associates, also in Tampa, Florida. Tim, can you give us a hint of what's in store for us?
Yeah, Lucky. In this episode of Rumble, we're going to hear from two well-known geotechnical authorities as they enter the ring on the subject of helical piles. Most of our listeners have likely noticed the upward movement in this sector of our industry over the last 5 to 10 years. But even if they haven't, this episode has a lot to offer. So let's take a look at our ticket. First, we have Dr. Kevin Johnson. Kevin is a senior engineer with EarthTech LLC in Tampa, Florida. In Kevin's years with EarthTech, he has been involved in dozens of helical pile projects on the contractor side of things and is a solid proponent of the technology. In the opposite corner, we have Mr. Ross McGillivray. Ross is a senior consultant with Ardaman in the Tampa area. Ross is a well-known and highly respected engineer and has been a stalwart in that region. His perspective is one of the geotechnical consultant who relies on many different technologies to meet the demands of his clients. Ross is here to ask some hard questions, probably some of which are also on the minds of our listeners. We are exceptionally grateful to these two geotechnical experts for their willingness to join our podcast.
Thank you, Tim. And thanks to Dr. Kevin Johnson and Ross for joining us. And it's very interesting. My first introduction to helical piles was in 2009. I'm very interested to see all the things you both have to say or don't want to say. Good luck and see you soon.
All right. So let's have well, there we go. We got the bell. All right, quick. Let's have a good fight and no low blows. All right. Kevin and Ross, welcome.
Thank you, Tim.
Thanks, Tim. Good to be here.
Good to have you. So in this first round, we're going to start out with kind of a warm-up with a little bit of technical background on the subject of helical piles. Kevin, would you mind sharing a description and maybe a little bit of background on helical piles for our listeners?
Yeah, absolutely. Helical piles, I guess, start with the most basic fundamental kind of defining characteristics. What you have to make a helical pile is a central shaft, whatever size, shape, or material it is, a central shaft. And then you need to have one or more helically deformed plates attached to that shaft. And those helical plates serve two purposes. One is to facilitate installation by converting a torsional energy to a downward advancement. And then two, they serve as the primary geotechnical resistance for the pile. Those helical plates, they need to be a true helix shape, meaning they need to have a constant pitch and they need to track the same path as they go down. And really that's it. That's all that makes the pile, and an anchorage at the top of the pile. And that's it. As far as their background goes, they've been around for a long time. They've been around since, I believe they got their start back in the early 1800s, and it wasn't until the 20th century with the huge advancements in hydraulic machinery and rotary equipment that really installation of them went from man and donkey power to actual machine power. And, ever since then, they've just grown exponentially. Historically, they were started out being used for light structures and underpinning, but people started using them in buildings. They got adopted into the codes. International Building Code adopted them in 2009, and that was on the heels of the ICC document AC 358, which came out just a couple of years before, which kind of laid the groundwork for setting standards on how these things need to be manufactured. And since then, they've been a part of the IBC and been used on buildings all over.
Very good. Well, thank you, Kevin. Ross, we're going to go to you. You have been in practice for some time. Is there anything that you would add to the description or background of helical piles? And is there anything that Kevin said that might come as a surprise to you?
Well, I was surprised a little bit on how early, but other than that, no, I think I understand, and I've used helical piles upon occasion. Used them once, actually telephone pole anchors to hold down a vault against hydraulic uplift, and we installed those, tapping on them with a sledgehammer and walking around in the circle with the bar. I've used them in some other locations, but you got to be careful when you use them that you've got the right application and the right soil profile. I don't think vertical helical piles can take significant lateral load. Kevin may argue that point, and I'll be glad to listen to it. And you need to look at the required load per helical and the depth of bearing to decide whether this is the type of pile that's going to work for your application. Underpinning light structures undergoing differential settlement distress, I'm okay with that. I've used them for that. But other locations, not so much. And in a very deep, soft soil profile, I'm not sure that's the right type of pile.
Well, that brings up a good point. That's kind of how the evolution of our industry has been, that we as technology come in, they take on there's really no such thing as a small project, but let's just say smaller, lighter projects. And then as that technology gets proven, it gets up, it increases in size and increases in probably their aggressiveness. So, Kevin, could you share with us kind of a range of applications or project size or soil conditions that you have seen helical piles be successful?
Yeah, absolutely. And I'll challenge some of Ross's points there. Yeah, we definitely use them for lateral loads. Lateral loading, it's all just a function. It's a round steel pipe. You definitely want to use the round shaft versus the square shaft for lateral loading. But then once you go to the round shaft, it's just a round hollow pipe like any other. And depending on the lateral load that you need, you just make sure you have the right size pipe. We've used them for lateral loads up in the 15 kip allowable range, I would say.
What diameter would that be, Kevin, for 15 kips? What diameter of pipe?
That would be a 4.5 inch or a 5.5 inch. We've used a 4.5 inch. No, I'm sorry. We for a 13 kip lateral load, we have used a 5.5 inch. And then of course it also depends on what axial load you combine with that, because you have to split that axial and lateral. We've done one application where we had 100 kip axial and a 12 kip lateral at the same time. And what we did was a 4.5 inch down the majority of the pile length, and then in the upper 20 feet we went to I believe a 7 5/8 inch. So that one was a pretty significant combination of axial and lateral. So we've definitely used them for were fairly high. You know, in axial loads, we've gone up to maybe 120 kips, 60-ton allowable loads. You know, load tested them up to, you know, 120 tons, 240 kips. But I've seen them. I've been, you know, I've not been involved with, but been privy to other projects and talked to others about projects where they've gone up to 200 tons allowable. These things with
200 tons.
With shaft, yeah,
Woo.
with 12-inch diameter shafts, and I've seen them up to 18-inch diameter shafts. I've seen it was either 18 or a 24-inch shaft and a 48-inch diameter helix. So they can get up there. It's all just a function of your pipe diameter, and do you have something to install it with? They get to be, the motors you install them with get to be pretty big, but that's really been the limiting factor historically, is having the motor to install it with. Once we get past that barrier, then, you know, it's still just a steel column.
So what's the longest you've installed or seen installed?
We've installed them down to 120 feet.
Whew, okay. All right. So if I could summarize, I'm just going to quickly summarize. You said that you've handled lateral loads. Now, is that with a battered one that you handle lateral, or is that with a vertical and you actually had a vertical pile handling a lateral load?
No, that's with a vertical.
Oh, so that's a vertical, and you've seen lateral loads very typical of, like, say 13 to 15 kips on a 4.5, 5.5-inch pile. You've installed some to 120 feet deep, and then you've seen them where they've almost put 400 kips axial compression. I'm just summarizing, kind of rough.
Yep, that's right.
All right, so
I would say 4.5, 5.5-inch shaft up to maybe, you know, a 15 kip lateral, you might be up in the 7.5 to 8 and 5/8-inch shaft. But
all right,
in that range, yeah.
All right.
Let me ask.
Go ahead, Ross. I was gonna get you in here.
Let me ask a question in terms of where you moved up to a 7-inch shaft, that shank, that makes some sense to me. But I see what diameter plate did you have? The helix did you have? Because it seems to me that you're going to get some slip no matter how perfect that helix is. It's not going to follow true. So you're going to get soil disturbed and loosened potentially around the shank. And I'm not sure what that lateral displacement might look like in terms of pushing against that loosened soil.
Yeah, that is a factor. There is a disturbance factor. On those particular piles, you know, we had up to a 18-inch diameter helix. That is a factor. Soil disturbance, and there's ways for accounting for that in your PY analysis. There's disturbance factors you can put on there. And we've done lateral tests on helical piles. That particular project, we did not do a lateral test, I believe. But we have done lateral tests, and we still get good results. We may get a little bit more than what the L pile showed, but it's not order of magnitude or anything. And of course, that would, you know, you also have to consider what kind of soils you're in.
I was going to ask you about that. Tell us about maybe a little bit. Clay sand, is one more problematic than another when it comes to helical piles, or really they're both adaptable?
Both of them are adaptable. You would have to consider for that lateral question that Ross was just pointing out, you know, you would want to consider what was in your upper 10 to 20 feet. If you've got a clay versus a sand, something that's versus where your water table is and everything like that. If you're gonna get soils collapsing back down around the pipe versus if you're gonna end up wallowing out a hole that's now, 2 inches bigger than your pipe is, yeah, that would be something that needs to be considered. And adding grout to these things can sometimes be a solution there. But as far as down at the bearing layer goes, sands or clays can be fine. Certain clays, if you've got a sensitive clay, that's sensitive to pore pressure, it's still not a problem. But you and probably talk about this later, but it may affect your torque correlations.
We're going to come around to that for sure.
And as far as the installing in deep, very soft soils, we have installed them. We've actually used them in several applications where we've got several feet of weight of hammer, either very soft clays or organics. And these projects have been brought to us because auger cast or some other type of cast in place pile isn't just really effective because it's just going to swallow up the grout. And maybe they looked at driven piles and it's just not economical, and we'll come up with a helical solution through there. Now we do of course have to consider the buckling state in that, and that is part of the design, and you have to get the right pipe size to account for that. But that's actually a common application of them because of that, because there's no grout involved.
Well, you brought up some innovative ways of using helical piles. Have you used them on slopes or embankments?
Slopes or embankments, we have not used them on slopes or embankments. We have used other maybe alternative piles. Actually, Ross and I were involved in a slope stabilization project where we did consider helical piles, but we ultimately ended up using some ductile iron pipe piles, and Ross was there. We actually did some controlled lateral testing in the shop, and then we also did some lateral testing out in the field to make sure they could take that. But as far as helical piles go, we have not used them for slopes. We have used them in some other kind of alternative ways. We have used them as rigid inclusions.
Okay. Ross, how about you? How about you, Ross? Have you have some thoughts about less traditional ways of using helical piles?
Well, I've used them as tiebacks for sheet pile walls, and they're good alternative there, with the exception that you've got to have a hole big enough to put the plate through and then patch that hole. So, but in the particular case that I used them, they were very effective. It wasn't a very tall wall, but there would be no reason why you couldn't spin them in if you've got the right equipment to do that. As far as slope stabilization, if you install them horizontally or at a shallow angle and put them in combination with an anchor wall type, like an anchored wall type situation, I can see them working. But as Kevin noted, I used the ductile iron to stabilize the slope of a dam that was settling differentially on the face and failing on the face, and that they were very effective, and I've been monitoring them now. We did that 2 years ago, I think, Kevin, and they're working fine. Nothing's moving, so I feel good about that. I've used drilled cast in place piles, vertical, to stabilize slopes. A project in Georgia, South Carolina border. In general, slope stabilization, I think with helical piles you could do it, but I'm not sure that vertical piles or soil nails aren't as good or better a solution for that.
I just wonder, were those anchors that you put in the sheet pile wall, how far back from the wall face did you extend those helical piles horizontally?
you would treat them as if they were a little anchor wall. So they've
Okay.
got to be outside of their passive zone has got to be outside of the active zone of the wall. So
So
they
that's
go
pretty
back.
far.
That could be pretty far on a tall wall. This was not a real tall wall, so it
Okay.
wasn't that big a deal. They weren't that long, but if you could put one in, I don't know, Kevin can tell us how long he could put in a horizontal one. That's an equipment controlled system, I would think. But you'd probably be using something like a 12-inch or 14-inch plate, something like that.
Yeah, it could be done. Probably something with it would depend on the exact application, but I mean, there would really be no limit to how long of a pile you could put in horizontally. You know, it would just depend, but it could absolutely be a feasible application.
Well, Kevin, how well do they pull themselves in versus you need crowd or push on them to keep them moving?
They pull themselves in to where you need little to no crowd. If those helices are actually manufactured well, and you're in good soil, you're in a medium dense or medium firm or medium stiff soil, they will just pull themselves down with little to no crowd, and that's the ideal situation.
Very
So
cool.
I think in a soldier pile wall, they would work extremely well. In a sheet pile wall, maybe not as well because of the having to go through the wall with the plates. But for a soldier pile wall, you don't have that problem. They could be a great solution. I've not used it for that, but I wouldn't. I never say no to anything. Basically, I'm going to look and see what looks like it might work.
I think that's true about geotechs. That especially consultants, right? We look at the whole tool bag to find the right one. All right. Well done, gentlemen. That's the end of round one. So let's take a short break and we'll be back. Okay, we're back for round two. We spent round one discussing the background and use of helical piles. Now let's shift gears for round two and talk about construction techniques. Helical piles can be installed in a variety of ways. They can have a torque motor attached to a backhoe where room permits, or in tighter spaces, they can have their installation performed by a handheld torque motor. In many cases, helical piles are used for underpinning, so room is often a scarce commodity. So Kevin, let's talk a little bit about installation. What's been your experience with helical piles in tight spaces? How easy would you say their installation is, let's just say, for inside of a typical office building?
Oh, this is one of the areas where helical piles really shine. They're great for this application. Just to start with, I mean, there's no vibration, no noise. There's, very often no grout involved, so very little mess. There's also no spoils. So all that makes it really good. And then they can be installed with, any range of equipment, depending on the size and the torque that you need. We've installed them with a mini excavator. We've installed them with a Bobcat skid steer. We've installed them with a 35-ton excavator, and we've installed them by hand with a bar, just a long bar. We've had to install them in an old historic hotel just for some shoring anchors, and we had to just twist them in by hand. We've also installed them in some tight spaces where we had to install some rather high capacity ones, and so we We installed them. We needed a 90,000 foot-pound motor, but the rig that was needed, which was either a 25 or 35 ton excavator, which was needed, was not fitting there. So we mounted the motor to something smaller, a skid steer or something, and we tied them off things. We've used other things because you have to keep that rig stable while it twists, and then run the hydraulic hoses out to the excavator outside so that it could actually run the motor.
Kevin, that's awesome. I mean, that it certainly is noted that helical piles are very flexible and they can be installed with a variety of ways. But, you know, from a consultant standpoint, you know, we generally like to see things done over and over again so we can get an empirical basis. Ross, you're the designer, for example. Let's just say you picked helical piles for your project. Given the fact that there's a range of different ways to install them, what installation data do you want for your design?
Well, I'm going to base the design basically on a soil profile I get from cone penetrometer indoor borings. And so I know what the soil profile looks like, and I know where I want the bearing to be. So I've got a pretty good idea, and I can calculate the bearing capacity of that helical and have a pretty good idea of where it needs to be to do the job. But I want to know the depth, and if I can get it, I want to know the torque. But I don't rely on the torque for capacity. I'm relying on the torque to tell me that I got into the layer that I wanted to bear in. So, because the torque tells you nothing about what's below that helical. All its measurements are at the helical. So if and I think the weak spot is if you've got a situation where you have something weak below a hard layer, that may refuse the helical. That's where the problems can come for. So you want to be sure that you penetrated the zone where you were expecting to get the bearing that you were looking for. And then as far as uplift resistance, I think the torque does give you valuable information in terms of soil strength, because there the plates penetrated the layer you're expecting to generate your resistance in. So if the loads are high, the appellation, you know, I want some load tests generally, except in very, you know, where I know I've got lots of capacity and I'm underpinning a light building, and I'm just going below the layer that's causing differential settlement, let's say, then I may not be worrying about a load test, but otherwise I would certainly want load tests. And if I was using it for lateral load, I sure as heck would want a load test, just like we did on the ductiles to verify that, yeah, we're going to get what we think we're going to get.
Very good. Very good. Kevin, let me follow up with you on one of the things that Ross said, and that is the relationship between torque and axial capacity. So, you know, I've read some of the literature, and I'm sure Ross has too, because he brought it up, and where there is a correlation between torque and axial capacity, but the engineer in me tends to think, boy, that may be true, but it always needs to be qualified. In other words, just simply, if I were to walk out to a site and install a helical pile and get a torque and just, you know, wipe my hands clean and say, I got the axial capacity, that seems to be, could be a little bit, I won't say, you know, that'd be concerning. So what's your take on this? Is the torque versus axial capacity, is it black and white, or is there qualifications that need to be made?
No, there's definitely qualifications, and I will almost 100% agree with Ross on this one. However, those correlations, there is a lot of empirical data out there to support those. But again, you do have to look at your application. Those torque correlations, there's only a ton of data for certain size shafts, anything from a square bar to a 2 7/8 round up to maybe a 4.5 inch. Once you get bigger than a 4.5 inch pile, it kind of goes out the window. And you also have to look at your soils. Torque correlations are really good they're really good in granular soils, and some clays too. We almost always perform load tests. I can think of maybe 1 or 2 jobs that were just very small, lightly loaded underpinning type jobs. But even the light ones, we do a load test. We always do a load test, and we always perform a theoretical bearing capacity calculation. So the torque is a good QA QC measure, and it tells you a lot of information about that installation, about the soil profile that you're in, and about the condition of your pile. But no, I agree. A load test is always important. We almost always back it up with the load test.
Well, let me ask you this about load testing. So I love load tests. I kind of think it's one of the fun things where you actually get to see things perform and evaluate how good our predictive models or predictive calculations are. I've not performed a load test on a helical pile. Is it common to instrument them? And what instruments would you put in one if you wanted to, say, get the distribution in axial load along the helical pile?
I've seen them instrumented. I've seen them instrumented both, in the research world, but I've also seen them instrumented in practice for jobs. And usually it's where the interior of the pile is grouted and they've dropped a bar down in there and tied some sister bars off to it. I've never done an instrumented helical pile load test. I've done a ton of load tests on helical piles, but not one instrumented with sister bars. And I've done both static load tests, and I've also done dynamic and rapid load tests on piles. And then those are, of course, instrumented with the accelerometers that are needed for that. But
no, I was going to ask you that same question. Have you ever run a dynamic test? That was one of my questions. So you have actually performed a dynamic test on these?
Yes.
Well, what do you think?
I want to see that data, Tim.
I know we got to get the PDA guys back out here. We get Paul and Greg to fight over this. Interesting. Wow. Okay. So, Ross, I want to come back to you. Let's say that you are engaged and you've got a specific project. Tell me what would be the conditions of those projects that would make an ideal helical pile job?
Well, for me, as I said, an underpinning situation where we've got a building that's performing poorly, you can't go banging around next to it. You need to do something that's not intrusive, and helical pile is an ideal application for that. And you can in there, I'm going to expect to have a shallow peat layer or some other soft layer that's causing the settlement problems that we're trying to get through down to a more firm layer. And so it's pretty easy to tell when you got down to where you need to be. And I think it's pretty easy to figure out that, that if I have this size plate, it's going to carry this size load, and that's what I need to stabilize the structure. So that'd be my primary use of the system. As I said, I've used them for anchored wall type approaches, And I could see that they could be a good way to do it. And I would certainly consider helicals for that. Again, especially if you're in an environment, urban environment, for instance, where you're worrying about disturbance and adjacent buildings, because you got to reach out beyond that wall. You're getting off your property line here, and you don't want to be causing problems with the neighbors. So a helical might be a good solution there. I wouldn't want to use it. I wouldn't want to use it in a situation which we have often in Florida, a hard pan layer down around 5, 6, 10 feet that's underlain by loose material or soft material. Because getting that auger through that hard layer is going to be a nightmare if you can do it at all. And but you've got the risk of punching if you put any significant load on it on that thin layer. So that's an area where I would not consider the helical as a good solution. So, and real deep, thick, soft layers, I'm still on the fence on that. I would have been an absolute no before Kevin was talking, but if he can convince me I don't have a buckling problem, then I might consider it for that. Also, where you have, let's suppose I've got significant uplift that I need, but I've got a very soft soil down to a very hard layer that I can't penetrate with the Helical. I'm not going to get a lot of uplift capacity out of it. And I'm not going to be able to get through that hard layer. And that's where a micropile approach is going to be a better solution. So you got to fit the solution to the problem, basically.
No, in fact, I was going to say something similar, and that is that, no technology that we have is applicable in all cases or the best solution in all cases. So it's really not a knock against helical piles, that there are some cases that are more optimal and some that are less optimal, or maybe some cases where like you mentioned, the hard pan. I could think of a couple of different technologies that could hang up shallow, that you don't really want that. You want to be able to, because the worst thing that you'd want to do is to hang up on something hard, only then to be kind of burned by settlement or maybe some sort of structural punching down the road.
Yeah, that's exactly right. And let's see, we have that condition a lot in the south part of Florida. There's that shallow limestone hard pan, and a lot of areas down there, they're just not a viable option. Sometimes they are, that layer varies, but we have gotten in situations where we've refused a lot earlier than expected. When we do a helical design, we always look at the soil profile. We look at what torque we're expecting to get, and we're always expecting to get that torque within a certain range of depth. If we hit it too early, then the operator knows to call us. If we get to the bottom of that range and haven't gotten any kind of uptick in torque, then they know to call us. Also, the nice thing about being a design builder, having that direct line of communication with the field. But yeah, there's definitely the same thing with the uplift application. Another one that you have to be careful with is liquefiable soils. We had a project where we were going down to our bearing layer, but there was some liquefiable soils up above, and basically we had when I say we're looking to get our expected capacity in a certain range of depth, we had a very, very narrow range that we were looking to get that in. So yeah, there's definitely applications where they're not the best solution.
Hey, great job. That was awesome.
They both did amazing, Tim. They're sailing very well.
Oh man, this has been wonderful. I've learned a whole lot.
Yeah. And I really like the perspective of, Ross, who has been in the industry for a very long time and talking about like how he has been designing helical piles and the do's and don'ts, and Kevin, who is installing it. It's really nice to see their perspective.
Well, I can tell you that, I haven't got nearly the amount of experience that Ross has, but some of the same questions I have had. And so I'm really pleased that he's brought them up.
Yeah, yeah. And I know in the next round, I'm sure they're going to spill a little bit of blood on each other, I'm sure.
Oh yeah, this is,
Uh,
this is the deciding round, right? So they've really got to go for the jugular on this one.
yes, yes.
I can see Ross smiling.
And I'm really interested to see, they did speak a little bit about, geotechnical parameters and also obstruction management, right? If you hit any kind of obstruction or if you hit any hard layers, you know what to do. And it would be nice to hear a little bit more on consultant's perspective, and he's looking through the geotechnical and contractor's perspective for installation procedures. That would be really interesting to see.
Mm-hmm.
Yeah, well, there you go, gentlemen. I think I'm looking forward to seeing like how much blood you will be spilling and how well you will be doing. Who will be the winner? Let's see.
All right, we are back for our third and final round on helical piles. So our first few rounds, we've looked into construction aspects, design aspects, a little bit of background information. And now what we're going to do is kind of look at the communication between the consultant and the design builder or the contractor and see what their expectations are with one another. So Kevin, I'm going to start with you this time. You guys do design build, I assume, right? A lot of design build. Okay.
Mm-hmm. Yeah.
Would you say you do more design build than design bid build, in particularly with helical?
Absolutely. Yeah. 95% design build.
All right. So here's your chance. Tell us a couple of things. First, you can tell us what information do you think a consultant should include? And I guess I should, let me reword that. What information would you like to see in a geotechnical report to help you with your design build?
In the geotechnical report, a good set of borings, really, is the main thing.
Borings or CPT?
SPT. SPT for helicals, I think, just because you can get a better classification of the soil type. That also varies from region to region around the country. So it could go either way, but in general with helicals, I want a good understanding of what I want someone to have seen a sample of that soil. But it's maybe the problem we run into a lot is maybe the depth of borings. A lot of times we'll get a set of borings and we're asked to give a price for helical piles, and we just have to say this is probably a good helical profile, but we're not going to get capacity in 25 feet. So, we'll probably end up going deeper. We just don't know how much deeper. And, we can give you a unit price for extensions, but as far as the geotech report goes, just a good set of borings.
What would you say is what depth would you like to see the borings? Would you like them to go down to rock, or would you like to see them, like 50 feet, or what? Tell us, the geotechnical consultants out there, they want to know, what do you want to see?
Yeah, I would like to see them go down to either rock or some very dense layer. Right. Depending on the size and loads on the building, I want to see them go down to some kind of bearing layer, something that can be considered a bearing layer. I mean, really, it would be that way for any other type of pile you were putting in. I don't want to see a boring that goes down and stops in the middle of weight of hammer muck. It doesn't tell me what's down below that.
Well, any lab tests?
Lab tests. If we're talking about clays, if we're talking about clays is the only option we have for a bearing layer, or is the best bearing layer down there, yeah, lab tests absolutely be valuable.
What do you think? Atterberg limits and moisture content, is that enough?
Yeah, I'd want Atterberg limits, moisture content, maybe in some cases some shear testing.
Okay.
But Atterberg limits and moisture content will tell you a lot.
Okay. Ross, what do you want to see in a design builder? You have made some recommendations, and then the owner has come back to you and said, Engineer McGillivray, we're going to give you the set of plans of the design builder, and you're going to review them. What information do you want to know about from the design builder?
Well, first thing I want to do is argue about SPT versus CPT.
Oh,
I am a cone head. My son, for years,
Ross is
working
CPT
for Paul
for that.
Main. I will tell you, I have done projects. We did a project here in Florida when Joe Amon was around, where we did borings, and Joe came to me and said, Ross, can we send the cone over and get some good data? So the reality is a cone, and in fact, I did the same thing in Louisiana on a sound well project, where I convinced the Louisiana DOT that they'd be a lot better off doing CPTs than borings in their soil profile, because one, you get a very continuous sample. Two, you get extremely good correlation with strength. I can do a strength profile that's extremely detailed that you can't get out of SPT, where you're doing a SPT 5 feet later, you do another one, and so on. And I know they say they do them at strata changes, but it's every 5 feet. Let's be real about it. And it's nice to see the sample, but I have taken the boring logs that we have, where we have both borings and CPTs, and plotted the N60 value against the calculated SPT-N from my cones, and the soil profile classification from the cone, and the agreement is amazing. So to me, the continuity of CPT will give me way more data than I can get out of a boring. The downside of a CPT is if I hit the shallow hard layer again, I've got to drill through it in order to continue the CPT, or I can't get data below that point. In general, you'd like to have both, and you can live with SPTs. I have for 20 years or 30 years before I became a cone head, but that's the one thing. But from the standpoint of the designer, I like to take something like a helical or soil nails, or even micropiles to some degree, as a cooperation between the consultant engineer and the contractor as a designer. So a design build approach. And I think helicals are one of those that fit into a design build approach. So for instance, if I've designed a project for a pile foundations, and Kevin comes and he says, well, I think I can do this job with helicals, I'm not going to say no. I'm going to say, prove it. Show me. And if it looks like it's going to do two things: one, it's going to solve the problem, it's going to give me the capacity and performance that I need, and two, it's going to save the owner money, then I've got to agree that that's a good solution. So that's the approach that I would take, Tim. I want to get really good soil profiles where I can, and then give that data to a qualified contractor who knows what he's doing, and then work together to solve the problem. And we did that on our slope stability problem, where I was able to go over to the yard and we sat up and worked out a scheme to run the lateral load test to make sure the piles could take the lateral load I wanted to take, just the pile itself. And then in the field, how did the install piles work? And so we got really good data and ultimately very good performance. And that's the way I want to approach a project. I don't see an adversarial role between the engineer and the contractor. I don't think that does anybody any favors. But that's kind of my 2 cents in there.
Well, Ross, I love that. I love the statement you just said. I don't see it as an adversarial relationship. So tell me if you can boil it down to 1 or 2 ingredients in that relationship that make it successful, what are they?
One is that they have somebody who knows what we're, is talking on the same level. Like, for instance, I get Kevin at Earth Tech, who's got geotech and can understand what I'm talking about. He can understand what I'm talking about. So we're not talking past each other. Or contractors, and I remember one time, Tim, I doing a legal case, and an engineer friend of mine, we were talking about the case, and he says, what? He said, he's trying to read the book to the contractor. Well, the contractor can read the book better than he can. and so you don't want to get yourself into a fight in that situation. You haven't done the owner any favors. So I'm looking to have a contractor that I can work with. And he doesn't have to be an engineer if he's got the experience and has been around the block and knows his equipment. He knows what he installs, and he knows how it works where he is. So that's what I'm looking for.
All right, Kevin, same question for you. You obviously work with a lot of consultants. What few ingredients would you say are key to those successful ones that you walk away and you, like the one that you had with Ross, where it was a success all around and everybody walked away pleased? What's the secret sauce?
Yeah, in addition to what Ross said, communication, of course, communication and an open mind. And, I also don't want a consultant who, once I do suggest something or propose something, they just throw their hands up in the air and say, okay, we're out of this now. I do want your input. I want that input from the geotech consultant. I rely on those geotechs all the time. So I want it to be a two-way street in those situations. So, yeah, and I will go back to the SPT CPT thing. I will say that Ross's and Ardaman CPT soundings are the best CPT. I would take those CPTs over any SPT. So,
well, one thing, and I believe I recall correctly, but it's been years. We use a lot of CPT, but not necessarily in a closed area. But I do remember that asking someone if they had basically a hydraulic press that can be bolted to a floor slab, and they could push the cone, and they did. And so they were able to go inside of a building and actually push a cone through the floor, which I thought was probably the best data you could get in that condition, bar none. Anyway, otherwise, I mean, you'd probably be doing a hand dog or a DCP or something.
We had one of those rigs. Did you ever get to use that rig that we built at USF, Ross? The little CPT that could be bolted to the slab and yeah.
No, I never did. But I've done CPTs inside of buildings before. I used to have a little rig that would would go that small, but the mini cone system, and that's what you built. You built that small diameter, kind of after the sage cone type approach.
Yeah.
It was inch in diameter. It was a great approach. We don't have it anymore because it kept breaking and it's too costly to maintain. But any rate, now you want data, you want communications, Tim. That's the main thing, and you want to feel comfortable that when you're talking to the contractor, he's willing to listen, and the contractor knows you're willing to listen. If you've got that, you have a good job. I've always said, if any construction project comes out of the ground clean, you're going to have a good job. If you have trouble coming out of the ground, it's going to haunt that job all the way through.
That's great.
And so that's where the geotechs kind of get shortcut, because we're a second tier consultant, and sometimes we don't get to make all the choices we would like to make. But if we can get the project out of the ground, they're going to have a good project.
That's excellent. Okay, I've got one more question for each of you. Kevin, I'll start with you. What's the next step for helical piles? Where would you like to be with the helical pile industry, say, over the next 3 years or so?
You know, I mean, I think it's headed in the right direction. They are getting accepted more and more. I mean, I see them being used on bigger and bigger projects and higher capacities. You know, with helical piles kind of a unique situation because you have an extra player in there. You also have the manufacturer. You know, with helical piles, you're not taking raw materials. The contractor isn't just taking concrete and steel and putting them together in the field. You have to rely on that manufacturer as well. And
well, let me throw this out there to you. So, and I'll throw this also to Ross in a minute. Helical piles have come up a little bit different route. There really is an overwhelming amount of like journal articles. There's plenty of like conference articles and magazine articles and manufacturer research, but we don't necessarily see, I wouldn't say the same amount is in the academic world. Is that fair?
Yeah, that's fair. There is some in the academic world. You know, I believe University of British Columbia has had quite a few helical pile studies that have been really good with helical piles and sensitive fine-grained soils. And I think it was a DFI published paper last year. I think it was University of Toledo.
I saw that
good one. Helical pile anchorage, which was an excellent one because the anchorage is always a huge gray area. It's this overlap between the pile contractor and the structural engineer. And so I think things like that are great. And there should be more of it in the academic world, like you said.
Very good. Okay, Ross, last question for you. So I just brought it up with Kevin that, you know, we haven't seen probably compared to other types of foundations, kind of that the development in the academic world. Do you feel like that's necessary, or do you feel like we can bypass it and we're still on the right road?
I really think you can bypass it because practicing engineers aren't really looking at journal articles at this point in time. I mean, back 20 or 30 years ago, there was a very close link between what was going on in academia and what was moving out into the construction and professional applications world. And now the journal articles have begotten to be so scientific as opposed to engineering oriented that I don't know that they're useful. So I think publications like DFI and conferences are the better source and the more likely places that you're going to get the practice, where you're getting case histories, where you're getting application-oriented development rather than pure way out scientific type stuff.
Gotcha. So you don't think, so you don't, and I mean, so you don't think there's a little bit of like legitimacy that's assigned, or it used to be. I mean, 20, 30 years ago, if it was published in whatever, the geotechnical journal, it kind of lent legitimacy to the process. But what you're saying is that's probably changed now. The paradigm has shifted. It's not necessary.
I think so.
Okay.
I mean, I have a copy of Casagrandi's flow through, seepage papers
Sure.
that he did in the Boston ASCE. So, at one time you were getting real engineering applications that you could get your arms around and say, I'm going to use that. When Peck and these guys were really connected to the construction world. And I don't see academia as connected anymore. There are professors who are. I mean, Gray Mullins at USF has done some fantastic stuff. And some folks at Georgia Tech and Auburn are doing good work that you can actually apply to what's going on. So I'm happy with conference papers and
Okay.
professional organizations like DFI's publications. I think they do a good job.
That's great. Okay, gentlemen, we're near the end, but what I'm going to do is just open it up for maybe any last thoughts. Ross, we'll start with you. Any final comments for our listeners?
Well, I have one comment I wrote down. I think it was, I wouldn't rule out helical piles on any project. I might not put them out front myself, but I would be willing to consider them. But I would be very careful about when or where I propose them. And the problem that I have as an engineer is I don't get to select the contractor. So I have contractors I have a lot of confidence in, I work with all the time. But there are some contractors out there, small guys, and some of them do helicals for sinkhole type work. And to me, they're scary because I'm not sure they know what they're doing. And so when you put out a system which may require a little bit more engineering and a little bit more technique from the contractor, if you put that out front and it gets bid and the low bidders in there, that may not work out real well. So I'm perfectly happy putting out a sure thing and then letting somebody like Kevin come to me and say, well, we think we could do this on helicals, and here's why. And as I said, if we can save the owner money and I'm happy with that we can get the results, then I'm all for it.
Very good. All right, Kevin, you get to have get the final word.
Yeah, I mean, I agree with Ross's final thoughts for the most part. I'm biased as a design builder, and helical piles have just kind of evolved that way, kind of similar to the way ground improvement has. It just kind of lends itself to being a design build specialty contractor thing where we come in and say, hey, we know what we can do with our equipment and with the manufacturers that we work with and our methods. We know that we can get these piles in and get capacity out of them. But I just think more, an open mind and more communication between all parties, specialty contractor, geotech, and structural engineer, and the helical pile manufacturers. I think they're a great and very, very economical pile in many situations, and one of the probably historically most underrated piles. But I think they're coming up quick.
Very cool. Gentlemen, that was wonderful. Lucky, I'm passing it over to you.
Oh, yeah, thank you. I think they did very well, Tim. I'm very pleased at the way Ross was, bringing in examples, and Kevin was actually, giving his perspective as a contractor. I really like the way they tackled the last part of round three. And at the same time, I think, Ross and Kevin both had similar things to say. Listen carefully, right? It doesn't matter if you are a design engineer or a contractor. And data, right? I'm not surprised to hear data and communication is the main key, because that's the main key for everything that we do, right?
No.
That's the key.
In fact, I couldn't help but thinking while we were talking that if I had a project, I want both of these gentlemen on my team.
Yeah.
I find that for whatever reason, that there's almost immediate conflict in many of the projects I work on, and I don't know where it stems from. But the fact is that we all win when the project wins, and the minute everybody gets that, and Ross got that, Kevin get that, they're talking about it. If everybody agrees that the winner is everybody when the project does well, then a lot of the stuff gets solved, and we get the best solution, and it's applied in a proper technical manner.
Yeah. And I think Ross and Kevin both had a wonderful thing to say about, DFI and technical associations like this, right? I think they are the ones who are advancing the technology, and they are the ones who are bringing people like Ross and Kevin to talk about it. And Kevin, I think I need to congratulate you on the workshop that, that just happened, Helical Pile workshop through DFI, where you brought in the contractors, designers, and also the students to learn what helical pile world is, right? To show them, because in schools, like, they only see a little bit of it in the textbook, but not really know exactly what goes behind the design, and also the technicality of installation. So congratulations for a successful event.
And and I'm also going to plug the DFI journal. Ross, I couldn't agree with you more. Some of the technical journals are now academic driven and really have a hard time bridging with practice. But I will say that the DFI journal, it really embraces practical solutions. I mean, there may be some things that are more scientific, but there's certainly a lot of stuff that is much more driven by the practicing engineer. And so I'd encourage anybody that, may not find the right outlet with a conference proceedings, or they just simply, find themselves where they can't get to the conference, look up the DFI journal.
Yeah. And thank you for wonderful comments that you had in the perspective. And I think this will be a very good episode for people to learn more about helical piles, and people who use it as well, brought back memories for me. So I'm sure there are a lot of people who will get memories back. Thank you. Thank you so much, Ross. And thank you, Kevin. Thank you, Tim.
Yeah, that was great. Y'all are naturals.
Yeah. And this concludes our episode of DFI Rumble. And there is a lot more that's coming through DFI Broadcasting Common Ground. Keep your ear to the ground.
On behalf of DFI, we hope you enjoyed this episode. The views, information, and opinions expressed during Deep Foundation Institute's podcasts are solely those of the individuals involved and do not necessarily represent those of DFI. DFI does not verify or take responsibility for the accuracy of the information contained, nor does it warrant that the information contained herein is suitable for any general or specific use. The podcast is available for private, non-commercial use only. Editing, modification, or redistribution of this podcast is prohibited. Sponsored by ECA. Thanks for your time. Keep on surviving.